Alan Johnson, KU2Y, and this video is for building the AMSAT CubeSat simulator. This is the STEM payload board, part 1, and this is for the 1.3 beta version, these blue boards. If you instead have these white boards, if you look on them, the version of those is 1.2, and there's a different set of wiki instructions and a different set of videos. So these are for these blue boards. So here's the basic tools we need. We're going to be soldering, so I have my soldering iron, solder, metal curls or a sponge for cleaning the tip, some blue putty for holding parts while they're soldered, needle nose pliers, and side cutters. And I like having the bill of materials up on a phone or a tablet or even a printout. Right now, these are all checked here as I inventoried my parts. So as I install them, I'm going to uncheck them. And note that the actual bill of materials Google spreadsheet, you'll have to make a copy of it in order to edit it, in order to make your own check marks and notes and things like that. So let's just take a look at the instructions. So this is them here on GitHub, and again, make sure that you're on the version 1.3 here. There's the picture of it there. The boards once they're finished, the 3-board stack, the 3D printed frame, block diagram, parts, and then these are the 9 steps here. So this video is for step 1, or doing the first build of the STEM payload board. So these are the instructions we're going to follow, and there's the checklist there. Okay, so this board already has the surface mount components on it. You see the FM module here, the USB connector, and then smaller components. You see there's the low pass filter there and there, and there's also 2 1K resistors there and there. So if you're starting with a blank board here, you do need to mount those components. At the very least, you need to mount the low pass filters and the FM module. The USB connector, you can actually use these through holes on it there, and the 1K resistors can also be mounted as through holes. But I'm going to start with the version, and you can get this board with these surface mount components on it from the AMSAT store. Okay, so first thing that we're going to do is we're going to install J1. Now, if you ordered the parts using the Octoparts, then the parts will come and they'll basically be bagged up and they'll be labeled. For instance, here is J1, the 40-pin stacking header. Okay, so here is the part. Now, this is the only part that is mounted on the bottom. All the other components that we're going to solder here, we're going to insert on the top, flip it over, and solder the bottom. But for this connector, because they all stack together, you see on one side it's got pins, the other side it's got the female sockets. And you see here, J1, it's labeled on the bottom, and the outline, the rectangle here, is on the bottom. So I'm going to put it in here. Sometimes the pins are bent slightly. There we go. So that is installed in the bottom. And now we're going to flip it over here. And we're going to use these pads here, and we're going to use the fact that we want to get heat to the pad and to the pin, but we're also going to be careful not to let the solder get solder on the tip of the pin. Otherwise, we'll have trouble inserting other boards onto it. So, okay, so let's get started here. We clean off our soldering iron, and I'm just going to do 2 pins here, and then I'm going to check it. So there's 1 pin there, and do 1 pin there. Okay, so now I'm going to take a look at it here, and what I'm looking for is I'm looking to make sure that it's fully inserted, that there's no gap here. That looks good. I'm also going to look to see that it's at right angles, that it's not leaning one way or the other, because that'll make my board stack bad, but that looks good. So I think I'm ready to solder the rest of the pins. Okay, so I'm going to start halfway up here and work my way down. Okay, so I'm just going to take a look at those. Those look pretty good. You see how there's a nice little blob of solder there, but there's no bridging, and it also is not climbing up the pin. So that looks pretty good. And if your pins aren't soldering like this, make sure that your iron is hot enough, that your solder is melting. Also make sure that your tip of your soldering iron is nice and clean. It should be bright and shiny. Also try not to add too much solder. Okay, so that's one side done. Now let's do the other side. Okay, so I'm just gonna inspect all the pins, make sure there's enough solder, make sure there's no bridges. That looks good. Happy with that. Okay. So next part we're going to do is switch S1. So here is my switch. And now from now on, all the components, we're going to insert them here on the top. You can tell the top because it's got the AMSAT logo and the other writing on it. So I'm going to insert the part here on the top, push it in, and then I'm going to flip it over and solder it from underneath. This part has 4 pins, so I'm going to solder just 1 pin, and then I'm going to flip it over, make sure it looks straight, make sure it hasn't moved. That looks good. So now I can go ahead and solder the remaining pins. It's much easier to straighten a part or remove a part if you've accidentally put it in backwards or something, if you've only done 1 pin. Once you've done 2 or more pins, it becomes so much harder. So it's always a good idea to check it first. So you can see the 4 solder points there, and the push button looks good. Next, we're going to do the switch X1. So this is our remove before flight switch. And there's a little hardware screw here, which you really don't need since we're just using it as a switch. Again, we mount it here on the top. Now this is a little bit loose, so this is where I'm going to use some of my blue putty here. So I'm just going to pull a piece of it, and I'm just going to stick it across it, and that holds it in place there. So now I can flip it upside down. And again, I'm going to solder just 1 pin. And then I'm going to take a look at it closely, make sure it's in the right way, that it's inserted all the way. Yeah, it looks good. So now I can solder the remaining pins. Okay, and then this 1 pin here, I just want to move that. Okay. So you can see the 5 solder joints there, looks good. Okay. So now we're going to install the LEDs and the resistors across the top. So it's going to be 3 LEDs and 3 resistors. So we're going to start with the green power LED, which is LED 3, and the 1K resistor R7. So I'm going to find D here. Yep, here's LED 3. Okay. Now, to use clear lens LEDs, but you could use colored lens ones. Thing is, you just need to keep track of them and not mix them up. Otherwise, because you can't tell what color it is once it leaves the bag. If you're not sure, you can carefully check it using a multimeter. The other thing about a diode, in this case a light emitting diode, is that it has a polarity, so we need to get it right. And if you notice, one of the legs here, this bottom one here, is longer and the other one is shorter. There's also another way to tell. It's a little harder to see, but the bevel around it is flattened just slightly on the side with the shorter pin, and that side goes to the edge of the board. So that's basically how I'm going to mount it there. And now I need the 1K resistor. And again, since resistors look similar, you have to look at the color bands. And in this case, it is brown, black, red, which is, do it this way here, brown, black, red. Now, all the resistors we're going to mount are actually going to mount vertically. So we need to bend it over. And you can use pliers, or in this case, I can just bend it with my fingers here. Okay, so there's the two parts. LED 3 is going to go between the switch and the remove before flight connector there, and then R7 is going to go right next to it there. So now I'm going to insert them. Also, if you look at the PCB, you notice that that the bottom pin here has a little plus marked there, and so that's where the longer of the pins goes. So that's going to go in like that. And then the 1K R7, it doesn't matter which way you do it because resistors don't have polarity. So there they are inserted. So now I'm going to flip them over here. And just to give it a little mechanical strength, I'm just going to spread the legs a little bit here. So I'm just going to bend them slightly. So that gives it a little bit of strength. It also means they're not going to fall out now. However, it doesn't guarantee that it's going to be, that they're going to stay flush. So I'm going to use a bit of my blue putty again, and I'm just going to run it here, press down on it, and that should keep the LED and the resistor straight. The resistor doesn't matter so much, but the LED, since you see it, you don't want it to be crooked. Okay, so now we're ready. You can see the 4 leads there, ready to be soldered. So let's go ahead and solder them. I'm going to solder 1 pin on each device first. So I'm going to do 1 pin on the resistor, and then I'm going to do 1 pin on the LED. And now I'm going to check it. I can remove the blue putty now because they should be held in place. And it looks good. One last chance to double check the polarity. I don't know if you can see the flat on the LED is next to the edge of the board there. Okay, looks good. So let's solder the other 2 pins. There we go. All 4 pins are now soldered. And now we can trim them. You want to have your safety glasses on when you're trimming. Also, I like to just, if you just put a finger, if you just snip them off, they'll go flying and create a mess, and they could also hurt you. So I just like to put a finger on it like that, and that way it does not fly. Okay, so discard those offcuts. Very good. Okay, so I've been following along here on my checklist, so I've just been unchecking there. So next I have the R9, the 220 ohm resistor, and the LED 5, the red LED. So here's my red LED, which is the charge LED, LED 5, and again the plus is down, so it's going to get mounted like that. And then this is my 220 ohm resistor, and that has the color bands red, red, brown. Again, I'm going to bend him over so I can mount him vertically, and those 2 are going to go like that. So let's insert them. LED 5 and R12. Sorry, R9. And again, I'm going to use a little bit of blue putty just to hold them in place. And I'm going to bend the leads slightly. Okay. Looks good. So again, soldering 1 lead on each component. Now, take away the blue putty. Looks good. Everything looks straight, fully inserted. Okay. Check the solder joints. Looks good. And now I will trim them. There we go. So you can see the solder joint there. Okay. And then finally, we're going to do the blue transmit LED, LED 4, and R8, which is a 100 ohm resistor. So here is my here's my blue LED. And R8, my 100 ohm resistor. And the color bands on that are brown, black, brown. Okay. Bend him over. Okay. So I'm going to insert them. Again, the longer lead is the plus. Goes away from the edge. Insert the resistor. Little blue putty. Just to hold them in place. Bend the leads a little. Make sure they're inserted all the way. And now solder one pin board. Just be careful not to let the iron touch the plastic connector there. Okay, let's have a look. Take away the blue putty. Yeah, everything looks good. So I can solder the other two pins. Actually, I'm not sure about that solder there. See how it's kind of, I don't know if you can see, it's not making a good contact there. I think that's actually not a good joint. So I'm going to heat it up again. There we go, that's better. That time it flowed. Now I can clearly see the solder making the connection to the pin and also to the board. Okay. Now, if that had been a bad joint, this LED just would not have illuminated when we were doing the tests on step 4. So if the blue LED did not illuminate, then we would check all the solder joints. We'd make sure the LED is inserted correctly. Okay, looks good. So we've done those LEDs. Okay, so now we're going to install a regular diode, D1. So here it is. And again, this diode has polarity. And if you look at it, you can see this left side here has a gray bar stripe on it. And if you look on the board here, D1, here's where it goes. And you see the symbol has an arrow pointing, and then one side has a bar. So that's exactly the way we want it to be. So we want it to be like this. I don't know how clear that is. The wiki has a nice clear close-up shot of that. So we want to put it in with that polarity. So again, we're going to mount this diode vertically. So what I like to do is I like to put the stripe facing up so you can see it. So I'm going to bend that over. Lead's a little thicker here. Okay, so that's going to go like this. So the side with the stripe is going to be to the left, and the side without the stripe is going to be to the right. So let's go ahead and insert it here. Here we go. See, I have the stripe pointing up. And I bend the leads slightly. This holds in place, so I don't really need the blue putty. Also takes a little more heat. Okay. Make sure it's straight, make sure it's installed all the way. Looks good. Now I'll do the second pin. Okay, looks good. So I'm going to trim the leads. Okay. All right, so now we're going to install the 68 ohm resistors. There's two of them, R13 and R15. And you notice these are bigger resistors. These are actually half a watt resistors. All the other ones have been 1/10 watt resistors. That's because these resistors make up a attenuator circuit, which is used to reduce the power that's transmitted by the FM module. Now, if you're building this as a balloon payload, you probably want the full 500 milliwatts of power, in which case you're just going to jumper R14 and leave R13 and R15 out. But we're building this as a CubeSat simulator. So these are the two 68 ohm resistors. Color bands are blue, gray, and black. And so again, I'm going to bend this over there. And so it's R13 and R15, and then in the middle is R14. And R14 is a 180 ohm resistor. And that has color bands of brown, gray, brown. So bend him over. And again, this resistor does not have to dissipate any power. That's why it is it's just a 1/10 watt. It's much smaller there. Okay, so now I'm going to insert them. It doesn't matter which way you do them, but just so it looks nice, I like to do them all the same way. But resistors, unlike diodes, do not have a polarity, so it's not going to affect the performance of your circuit. And again, I'm going to use a little bit of blue putty here just to hold them in place, hold them straight. And I'm going to bend the leads slightly. Okay. Ready to solder. And now there's 3 components, so I'm going to solder 1 pin on each, and then I'm going to check them. Okay. Now you can see they're not perfectly straight. It has no effect, just the look of it. So, but I'm still going to straighten it. So I'm going to just bend this one out a little bit, and I'm going to bend this one over. And the pliers, I can just move this one slightly. There we go. Again, has no practical effect, but it just looks nicer. You do want them away from the connector because another connector is going to plug in here. You definitely don't want them touching that connector there. Okay, looks good. So now I can solder the second pin. Take a look. Now notice that these two here actually bridged. See how they're actually soldered together. Normally that would be a problem, but the way these resistors are, they're actually connected together. There's a PCB trace that does exactly that, so it's perfectly fine. The reason that I allowed the wires to cross like that is because it's okay. And the same thing with the other pair there. Okay, so now I'm going to trim the okay. See how that looks. Yep, looks fine. Okay, so that completes the soldering for this step, but we're just going to do one test here. I'm just going to plug a USB-C cable here into the USB-C connector, and if all goes well, we should see the red LED illuminate. So let's do that here. There we go. Success, nice and bright. So that at least proves out a couple of our components here. And in step 4, we will test the green LED and the blue LED as well. Okay, so this completes step 1 of the CubeSat simulator beta 1.3 build.